This conference will now be recorded.
All right, thanks for coming along, everybody, to the monthly IT&I and CDI Tech Stack webinar. This month we have Shane Crossman and Matt Purse. Matt gave us a really nice presentation about distributed global grid systems a few months ago, and we unfortunately ran out of time to talk about his second topic, which was this location index project that he and others are working on. So we invited him back to finish that body of work and to share kind of in depth what this location index project is about. And as I mentioned a little earlier, before we started the recording, this is part of what I hope to be kind of a series of these linked data and spatial kind of data integration talks that will have some presence of this material or this theme at the winter meeting, and I hope to carry this topic on in a few of our future talks. So if this elicits especially interesting things that we should focus on in the future, please do let me know, and we'll schedule some future webinars on these topics. So with that, I will turn it over to you, Matt and Shane. Please do introduce yourselves and take it away.
Okay. All right, for those in the room who don't know me, I'm Matthew Purse. I'm a senior advisor on geospatial standards at GS Australia, and the sort of one of the founding co-chairs of the OGC Discrete Global Grid Systems Standards and Domain Working Groups. So I've been working with Shane here in the location index for the past year or so. Sort of providing that sort of linkage into how discrete global grid systems can work in with the Loc-I project. Yeah, I'll leave it to Shane to give a brief intro, but yeah.
And hi there, I'm Shane Crossman. I'm the project leader for the Location Index project. The Location Index project is a collaborative project across Australian government. It's part of a program called Data Integration Partnerships Australia, which is run through our Prime Minister and Cabinet. And it's a collaboration between Geoscience Australia, the Australian Bureau of Statistics, Department of Environment and Energy, Department of Agriculture and Geoscience and CSIRO. And the project is around how we can look at infrastructure to improve data integration across Australian government. And part of what we're investigating with the Location Index is how we can use a semantic querying infrastructure to improve policy decision making. Essentially, that's the case study. What we're doing is looking at multiple geographies and how they relate to one another, and then using semantic querying to build queries. What I might start with is a video on just showing what the location index is about.
Everything happens somewhere. That makes information about location one of the key ways to link big data sets together. The problem has been that different agencies record location in different ways. Some use map coordinates, others use street addresses or administrative boundaries. Still others use gridded data for things like vegetation or native habitat, natural landforms, and features like river catchments. This practice of identifying the same place in multiple ways impacts efficiency and reliability of analysis. Questions get asked about people, business, and the environment every day, and the information that provides answers for the decisions government makes needs to be findable, accessible, interoperable, and reusable. Good data is essential if government is to formulate effective policies, services and programs. But without a standardised way of accessing and relating location data with others such as population, industry or climate, government often ends up with errors in any integration where location would be a key component to any meaningful analysis. And without a way to share the data, analyses remain within the department walls and, despite their great value, are seldom shared. If another researcher used the same source data for a separate project, he or she would have to replicate the process entirely. The Location Index, or Loc-I, will solve this problem. Loc-I will overcome this difficulty by automating the process and will introduce a level of uniformity to location datasets that will enable researchers to effectively and seamlessly integrate location data to produce accurate and repeatable results about people, business and the environment. Loc-I will also remove barriers to sharing through an agreed and consistent way to translate and connect different methods of referencing location across government data and, subject to strict privacy laws, make it available to the wider research community. So how will Loc-I be applied? By helping the numerous agencies from Australian government, state government and local communities use Loc-I infrastructure to make informed, accurate and data-driven decisions about how to mitigate the risks posed by severe weather events and climate change, groundwater quality and growing tourism numbers, how to effectively and efficiently mitigate biosecurity risks, and how best to mobilise a response to incursions, how to generate economic growth without depleting natural resources or reducing the value, condition or multiple use of available land. Location Index is part of the Data Integration Partnership for Australia, or DIPA, a multi-agency program that will open up new ways of integrating and analysing data from different domains in a consistent and reliable way by reducing costs in accessing the data, enabling fast and easy access to the data, enabling stable and repeatable access to the data, and reducing complexity in the use of the data. It will increase interoperability with other datasets and improve decision-making through the use of trusted data. It will also provide transparency in how the dataset was made and what is planned for its future. But the real measure of Loc-I's success will be the increased number of location-based datasets indexed and linked to support repeatable data integration in the future. As the community of subject matter experts accessing Loc-I grows, so too will the reference library of common analyses and outcomes.
Oops. What the video highlights is, I think anyone who's involved in government probably shares or understands a number of those challenges that happen when we're talking about integrating data. What we're basing Location Index on is that when we're talking about supporting policy decisions, that everything happens at a place or location, and that's the way in which policies usually are defined. Our society and economy sections of government transfer information through identifiers, but a part which is missing is the location part and how that integrates with one another. And that's essentially what Loc-I is trying to do, is to bring those three elements together. If you like, it's that missing jigsaw piece that's allowing for that integration. A key part of that is how we enable linking spatial and non-spatial data together, but also how we make data fit for purpose. And we want to make sure that it's got those authoritative sources, and we're using new and best technology to deliver these things. So our challenge. First of all, our challenge is, how do we move multiple geographies, whether or not they're observations in the sense of Earth observations, or talking about addresses or polygons such as water catchments, or what we call the geofabric. But how we move these things together when they've been described differently. But on top of that, we also have non-spatial and spatial information in tables. And this information also provides important contextual information, particularly around the Earth observations, which is changing the way in which we're describing much of our data. So challenge one, data integration. We want it to be accessible, and we want it to be fair, using those FAIR principles, not just to be delivered or just downloaded, which is something which we've done quite successfully, particularly around open data. It's been something that Australian government has used for quite a while, is that we'll make all of our information by default open. But that doesn't mean that it's necessarily accessible in the sense that it could be reused, and whether or not it's interoperable. I think we probably all know the FAIR principles. But the really big challenge for us is not so much the findable and accessible parts, but it's the interoperable and the reusable that we're really looking at. Our goal is to try and make location index a way in which we can use semantic integration of linked data, or being able to, whether it's linked data or linking data. So the power of linked data is obviously that we can discover it through the web. It's machine-to-machine communication, so readable. We're able to extend by linking or linking other data sources on the web. And we are able to reuse it, not necessarily based on why the information was originally captured for. And that it enables a consistent data mining, which means that we can basically do things in a GIS way without actually using GIS. Innovation technologies that we're currently looking at. We're currently testing linked data and the discrete global grid systems. And the reason for doing this is that we want to be able to understand the relationships between those geographies and how they could be reused. Building this innovation across multiple agencies, definitely not an easy thing to do. And there's a huge gap in resources and skill sets to do this. Implementing a set of new tools for semantic integration. While we can build the infrastructure and store the information, the real value of that will be what tools and applications we build across it. And then being able to reuse those tools and infrastructures, both in the research area of Australia, in the sense of the research vocabulary of Australia, but also how we move that research area into government. And we want to be able to implement both cloud and private repositories. Government will obviously require secure access of that integration, but we also want to be able to release it in an open way as well. Our goal, extending the system for reuse. We want it to be highly scalable. The amount of information that we're gaining now is outweighing the information which we've got stored. Everyone knows this problem. Secure, for government obviously needs to have a number of highly secure networks. We want it to be flexible. This is a part of which the discrete global grid's definitely playing a role in. And we want it to be repeatable. And as we deploy the codes within these various bit buckets and pipelines, obviously we hope that will become more easy to administer. Discrete global grid systems, those technologies. The main reason why we're looking at these is that, first of all, it's maths-based, which means that we can scale it and we can add information to it. It's also agnostic to a number of formats and projections, and this makes it quite useful, particularly as we're starting to go into the space of Earth observations and being able to connect other contextual information to it. The challenge which we've had with GIS systems over the past couple of decades is how do we actually integrate between raster and vector-based formats. Matt will talk a bit about this further down in the presentation. Social architecture is our third big challenge. We want to make sure that we improve that user experience and efficiency, and we want it to be human-related process. However, we've got a number of gaps within our institutional culture of how we do this. Oops. So central focus on improvement in governance is one of the key improvements that we need to do across Australian government, particularly in how we manage identifiers and those vocabs and ontologies in a way that becomes consistent, which means that they can be reused. So security, improving those data integrations between those partnerships, ensuring data currency, and enabling those multiple complex user requirements and use cases. Use cases are currently being developed under the Data Integration Partnerships of Australia, and there's another program called PIN. If you like, we'll send you a link to those web pages. These use cases are formulated in and around how data integration can improve policy decision making, and there's a number of those projects currently occurring across Australian government. And we want to support that user-centric approach. We've got a whole lot of information at the moment that looks a bit like spaghetti. And what we're aiming to is that location simplifies that approach to a more streamlined way of moving across government, rather than being in the video showed all those silos. Bringing it all together.
Yeah. So one of the challenges that we've got is we've got this, I guess, this stack of technologies that we're looking to implement as a way to drive that interoperability. And some of these technologies we have never been really put together sort of before, and so that presents a lot of opportunities, but also a lot of challenges in that. And so we've got, I guess, the two main sort of technologies being explored under Loc-I is the linked data architectures. So how we structured the data, how we provide access to that, or access points to that data that that sort of fits within the linked data sort of realm, and all of the benefits that derives. But at the back end, we want to be able to manage the sort of the authoritative data sets and their relationships in a far more flexible way than we would otherwise be able to do if we just statically did it. So like I said, I mean, we've got multiple individual data registries and data repositories. Now we can provide through the linked data ontologies and architectures, we can provide user-friendly interfaces to identify, discover, and as Sharon was saying, the applications sort of built on top of this will then allow people to then ask queries of and send sort of processing requests to those data registries in a flexible way to do it. So one of the challenges that we're sort of grappling is from a purely linked data perspective, how do you reconcile the relationship between different data sets and different geographies, different locations? And so what you can see on the screen there is a relationship, a linked data sort of relationship between different identifiers. And so on the left hand side, you've got the SA1 sort of a statistical mesh block identifier, and then you've got the different links off to the different aspects of that data through the linked data, and you've got a relationship. Well, this is within this SA2 sort of object or geography, which is a different I guess set of objects, different data set. And so you can do that. Now you can hard code these things, and CSIRO have been doing a lot of work in trying to understand how easy or difficult this might be. The problem you run up against when you do that just purely on a linked data perspective is that every time you create a relationship, it has to be minted, and it becomes a static thing. Now that's okay when you're only asking that same question, because then you get that efficiency of your repeated questions once that's been done. But it's the unanticipated question that, whether that's a technical or a policy question, that's the challenge that if Loc-I was just relying on linked data architectures, would present quite a challenge indeed. And that's kind of where we see DGGS technologies as sort of stepping into that gap, as providing that back end data management flexibility, but based on a consistent and common spatial framework. And with DGGS, you're able to do that same sort of object-to-object identify, or referencing, and but in a more scalable and flexible way, because DGGS is kind of like an underlying database type infrastructure itself. It's not linked. It's not implicitly, it's not explicitly linked to the data that it's storing. So we've got a couple of examples. You may have seen some of these in various presentations before, of some of the work that we've been doing within GS Australia and the Loc-I project to explore. I guess first of all, our initial approach was, do DGGS sort of fit in this space, and if so, how does it work, and what are some of the benefits? And what we found with one of our first pilots that we did in this space, where we took the water observations from space data product coming out of the Digital Earth Australia, and we provided it with the spatial context that the geofabric or the water catchments dataset provides. So we'll quickly sort of drill into this a little bit. But one of the big problems that the Digital Earth Australia has, despite its ability to wrangle massive amounts of satellite data, and to do that in a consistent and regular way, and to produce these sort of rapid analytical results, being, so this is one of them, being the water observations from space. The problem with that, coming from that just purely imagery approach, is that your objects that you are classifying, you're identifying your imagery, has no context in itself tying it to the real world. And sort of conversely, the water catchments have the context, because they're manually, or not manually, but they're built from the landscape, those data sets, and they're tied into that landscape, and they're identified based on that landscape. Whereas the objects that are identified in a product like the water observations from space, are given an arbitrary, well, not an arbitrary, but it's a computer-generated identifier. But it has no context to what's actually happening in the real world, and hence we get different. And it's complicated, particularly in Australia, because when we look at our river systems and which water body represents a farm dam and which represents part of the river, is that in Australia, being so dry, is that a lot of the rivers are actually puddles, sort of all the way along the river catchment. And so identifying, well, which puddle or which water body actually is associated with that river, and which is associated with something else, being a farm or some other operation. And that's been a real challenge for the Digital Earth Australia team, and for everyone really. And so we through the DGGS and the Loc-I sort of methodology at this problem, and we were very very impressed with how easy and flexible it was, and it allowed us to provide and assign the names of those rivers and water bodies to the remotely sensed and classified objects that are visible from space. So we're able to provide a value add to the Digital Earth Australia by providing the context to that data. So having done that, we then extended that into looking at, so that was sort of a contextual and technical sort of success. What about some of the socio-economic things? Is it possible to link the cadastre and agricultural statistics with data coming out of Digital Earth Australia as well? And so that's where we took it another slightly more complicated set of data products coming out of the DEA, being the irrigated, sort of the patches or the observed irrigated areas of land determined by a different statistical analysis of the satellite data. And we're able to again take that and compare that with the cadastre information. And what you can see on the screen there, you've got a whole bunch of red polygons being the cadastre, and you've got a bunch of green patches being the irrigated land, or the observed irrigated areas. And you'll see a bunch of dots everywhere. So you'll see some small dots and then some thicker dots. The thicker dots are the DGGS cells and the identifiers that lie within those irrigated areas, and the smaller dots are the ones that are within the cadastral areas. And so by doing that, what we found is by aligning and mapping both of those data sets to the DGGS, we're then able to use the cell identifiers, those unique identifiers, as the common link between these two very disparate data sets. Yeah, and so again, it was further confirmation that we might actually have a technology here that will really lend itself to allow Loc-I to realise its full potential. Yeah, so where are we at with Loc-I? Do you want to speak to this, Shane, or I'm happy to
Keep going.
step through? Cool. So this first year or so has been, I guess, the phase one, which is a lot of the exploratory, sort of an R&D sort of approach, where we've been testing out new infrastructures, validating, is this approach valid or is that approach valid, and to build sort of creating that concept and understanding, well, what actually do we mean by a linked data index, and then to start to build that capability as we've moved through that process, to build that capability of, we've got two very valuable technologies here that have similarities but are different, being the linked data architectures and DGGS. And we're sort of in the process of heading into that second phase now of looking at, so we've got an idea of the prototype of how it might all work together and all the bits and pieces. How do we operationalize that, and what's going to be the resourcing requirements in order for us to do it, and what are the tools that the potential users of this Loc-I infrastructure are going to want to use and interact with, so that as we sort of harden up the infrastructure to the supporting infrastructure, it's actually improving the user experience and leading to positive policy sort of outcomes. So some of the benefits that we've talked about today in various forms is Loc-I will enable the unlocking of the data potential. So it'll enable machine-to-machine data integration, analysis, and mining, and that's by sort of leveraging the linked data sort of data structure formats and the access. But through that, it removes the need for agencies to physically transfer data between themselves in order to do analysis. They can actually do that remotely, and the hope is that we can get to a place where the data doesn't actually move, even via linked data access. It's the query or the compute moves to where the data is. So, and we want to be able to support the acceleration of innovation in this space. We want to develop protocols, tools, APIs to enable quick multi-agency sort of data analysis on multiple levels, and we want to sort of test that the seamless data integration across those data sets using multiple and new technologies as they emerge. And of course, the people aspect is one of the most critical elements of this, and we want Loc-I to, and we see Loc-I as providing that opportunity for collaboration and to improve that collaboration across multiple agencies, multiple sectors, government, research, industry, multiple jurisdictions within each of those sectors, and to provide a common governance process and the supporting workflows to enable an authoritative government-supported spatial data infrastructure that helps us move forward. Any questions?
I certainly have one, but we'll let anybody on the phone go first. Thank you so much for that presentation. It's super ambitious, and I'm excited to learn more and kind of see how it unfolds. So, does anybody have questions? Okay, well, just to maybe hopefully kick off some questions, I'm on my way home from a workshop for an NSF open knowledge network project that has technically a whole lot in common with what you guys are up to. Loc-I. Sounds like you're working on how to pronounce that too. And the question we've been struggling with, kind of deep in the guts of the technology, is kind of related to your inundation example. But basically, if you had a model or a remote sensing information product that covers the whole landscape, but you actually wanted the quantities from that attached to spatial features in a like data infrastructure, are there good examples, or have you seen and or implemented examples of either sampling those in real time like at runtime as you're working with the linked data, or built the infrastructure to actually, as the remote sensing is procured or the model runs, sampling the values from those coverages or those surfaces to a linked data feature and populating a quote-unquote knowledge network through that avenue. And I'm just wondering if you have an experience with that, or any comment on kind of that coverage of time series being associated with the linked data as kind of a data asset that is available for a feature.
Yeah, I'm not sure if we've done that on the pure linked data approach.
I'll have a go at answering that one. So we've come across the same challenge. Yeah. So when we look at linked data itself, we're using just your basic graph database. So it's based on the predicate, object, and subject as being a triple store. And one of the things which we've looked at there is that we need to start also describing in the method and also time as components. And we've seen what you've just described then as one of the gaps that needs to be investigated. When we've been doing things with our Earth observation area, At the moment, it's been very much around a sort of a data request. And while the observations are changing on a daily basis, that contextual information that's coming through is not. And that's one of the challenges, I think, with having individual sources linked to the observation data. The challenge for us is that we know that we're not the only source of that data, and we can start to link that to other information which builds that contextual information on a more daily basis. So one of the, say, use cases that we've got here in Australia is how we're going to line up, say, our Bureau of Meteorology's weather forecasting observations and the Earth observations from our water from space, and then pulling that into irrigators. And that has a whole range of things of supporting both users in the sense of farmers and communities, but also it can also set parts on policy and decision making. It's a good challenge to have.
Yeah.
Totally. The use case we're exploring here is for urban flooding, where we have these models that can populate a estimated flood depth surface that's like something for the next 7 days. It might be a time series, it might just be a surface, and you actually want to be able to query the knowledge network, whether it's a Neo4j graph or a RDF graph, for places that are going to flood, but you don't actually have the value in the knowledge network. You just have a link to something that can give you the value. And anyways, I think it's an area that extending the knowledge graph through kind of runtime queries is something we're going to have to take on.
Yeah, that's kind of where we've sort of hit up with where we think DGGS as part of that back end supporting infrastructure can actually play a really good supportive role here, because it allows that flexible, as needed, and at whatever time frame too, spatial linking between data sets and observations, without having to necessarily hard code those. That's kind of the thing that we've sort of found, is that you've got that added flexibility of not being, from a DGGS, of not being tied to those individual observations and those relationships, but to be able to generate those on the fly, either as static outputs that then stay in a cache, and then when people hit those queries because they're interested in a particular problem or a particular sort of interplay of data, then they get the sort of the efficient and linked data supported sort of outputs. But then if they're asking for something that isn't in that cache, then it's not a drastic problem where you've got to redo the whole data set in order to get the answer. You only need to look at the patch you're interested in, and the DGGS allows that scalable sort of interaction to take place.
Right. Yeah, that makes sense. It's kind of a standard interface layer between the two worlds, which is good. I like it.
So one of the things which we are building over the next 6 months is looking at how, say, something like the cadastre, which is really changing on a daily basis, and particularly from policy decision, is that a lot of policy is built on the cadastre's identifiers, and that challenge of how do we maintain versioning and provenance of where these sources are coming from and connecting is one of the key components that we're looking at in the research space currently to manage. That will drive into exactly the same problem as what you've had with the irrigation.
And
it's
before
one
I
of
lose
those.
it, can you define cadastre real quick? It's not a common term in the States.
Oh, sorry. Cadastre is basically the dataset which defines our land parcels and ownership.
It's the ownership rights.
Right. Okay, that's what I thought it was. I just wanted to.
Yeah.
Sorry about that. What was it going to say? Yeah, no, I think that's one of our biggest challenges within this project is that we're somewhat learning on the fly. So when we say, do we have other examples and being able to see things in simple terms is no, we don't. And that's part of the reason why we want to reach out into these communities too, is because we know that there's a lot to learn from everyone.
I appreciate that. Copy success is an old aphorism that I took to heart a long time ago. So, and on that, actually, this upcoming ESIP winter meeting, there's going to be a workshop or a hackathon or whatever we're calling it before on coverage processing and APIs and ways of interacting with coverages, which is essentially this topic we're talking that I asked a question about. Is how do you want to be able to sample a coverage as a service and maybe hook it up to the data? But then I hope to continue that into the sessions and have some working time to really dig in a little bit on how to cross these two worlds. So.
Yeah, okay, that's really good, and that also links in with a lot of the discussions that are happening in the OGC space around sort of open APIs and interacting with coverages.
Yep, and that first sprint it's an OGC API coverages sprint that's OGC ESIP sponsored. So, yeah. And I see Megan is dropping some links into the chat for the winter meeting. Thanks for that.
Great. Yeah, that's good.
So anyways, were there other questions online at all? All right. So yeah, go ahead.
Oh yeah, I was just going to say. So we've given sort of a brief look into some of the use case examples that we've done, and I know David, so you and I we've been tic-tacking on on emails about the concept of having a third sort of Loc-I focused webinar, sort of where we sort of drill into some more detail about some of these use case examples, and there's a couple of other ones that we've been working on from GS Australia's perspective that we could sort of throw into the mix and present if that's sort of fits in with what your agenda is and what you want. We're happy to put that webinar together and deliver that in December.
Cool. Yeah, no, consider yourselves on deck. I don't have any other plans at this point, and I hope this is useful for other people. This is really useful for me. I'm pretty keen to continue to dig in and learn more, and it'll lead into the session that does she go by Irina or Irina? Anyways, Irina and I are bringing together for the winter meeting. So that's great. All right. Well, if there are no other questions on the line, I think we'll go ahead and call it last call.
Right. Thanks a lot.
Thank you very much for having us.
Yeah, thank you so much, and thanks for getting up early. I'll get this recording up. I'll get this recording up on YouTube, hopefully tomorrow. So.
Fantastic.
All right, have a good one, everybody. See ya.
See you later. Thank you.